I'd like to discuss a trial lens method for designing custom 15mm multifocal GP lenses using the Wave contact lens software. To create a trial lens set, what I did was I used a simulated surface. I would specify a K reading and a shape factor of plus 0.5, keep the simulated surface spherical. Then I would select from custom configuration a definition. I call it CS15B multifocal, and the reason is it's 15 millimeters in size. Corneal scleral lens. This has a multifocal, bifocal in it, and I had used the blending option and specified a lift angle for starting point, but was shooting for an apical clearance of 200. Now, after I applied this configuration setting with each simulated surface, I would fine-tune it and make sure I had an apical clearance of 200 microns, and then I would adjust the far right control point to create different lift angles, 30, I believe 26, and 34. For each one of these designs, I specified a multifocal with the center near add of about 3 millimeters so that it would be a little more useful to me clinically when I place the lens on the eye for a multifocal patient. After going through all this, I had a series of 24 designs ranging from base curve of 41 to a base curve of 48. Each base curve has 3 lift angles, 26, 30, and 34. And so I have this set of design files that describe the trial lenses that I have available. Now, applying this trial lens set, what we would do is we would take a topography and import it and follow the same methodology. We would use the same definition, this CS15B multifocal, and specify 200 micron apical clearance and begin with a lift angle of 30 because that's kind of in the middle of the lift angles that I have available. I would specify a lens power that was about plus 0.75 more plus than the refractive error. That gave me a pretty good alignment centrally. Now I would adjust that design, fine-tune it so that it had an apical clearance of 200 and a lift angle of 30, just like I did when I was designing the trial lenses, except remember this is with a real topography. Now at this point I could see what my base curve was that resulted in. The base curve was determined by the topography. So I could then use the compare function in Wave and select the base curve that was closest to what my real topography had yielded for me with a lift angle of 30 and compare that, bring that into Wave to see how that sort of trial lens would actually fit. When I've brought in the trial lens, it creates a blue line on the screen, and that is how this trial lens would align with this particular cornea. I can compare that to what my calculations on this cornea were and see how similar they are. Now what I want is for the blue line to be a little bit above the black line. If the blue line came out below the black line, then I would need to select a steeper base curve from my trial lens set until I had a pretty good agreement between the blue line, the compared trial lens design, and the design that I created using Wave. Then we place the lens on the eye. Once we've selected our trial lens, the one that matches as close as possible to the one that we've designed on the screen using Wave, we put that on the eye. And the best way to do that is without fluorescein at first, so that we can then, with the lens on the eye and with no bubbles in the lens, we can apply some fluorescein to the tear film and observe with the slit lamp if the fluorescein is getting underneath that lens. We want the fluorescein to get underneath the lens so that there is some tear exchange beneath the lens. There is about a 90 micron difference in apical clearance, or sagittal depth rather, for each base curve step. So if we apply this lens and we see that we have an excessive amount of vaulting, then we know we're going to change that by about 90 microns when we take a 1 diopter step in base curve. And conversely, if the alignment is too close, if there's not enough, then we know that by going 1 diopter steeper with this particular set of lenses that we'll have about 90 microns more tear layer beneath the center of the lens. Then we look at the edge. Now this is with fluorescein in the eye, and you can see this is the angle 26, 30, and 34. The higher the angle is, the closer the lens aligns out here in the periphery of the fit. And we observe that and select the one that we feel like is the best fit for what we want to see clinically. I kind of like this middle design here. I think this is a little too tight and this is a little excessively loose. But there is about a 70 micron difference in the lift at the edge of the lens for each 4-degree step. So you can get an idea there in terms of tear layer what these angles correspond to in terms of microns. Because we're doing this as a multifocal, then we can use handheld lenses to binocularly over refract to get our best near and distance vision. That's the easiest way to do it, and then we can take that information and from within Wave, click Tools and simply import the design that we have placed on the eye and that we took an over refraction with. And now we have that actual lens design on the screen. And when we do that, we will have the opportunity to enter a over refraction. So we can enter the over refraction that we got with our handheld lenses at this point. And if you see any adjustments, if you want more apical clearance, if you would like to fine-tune the lift angle a little bit, you can do that by adjusting these 2 points with the design that's on the screen. At that point you can click order, and then you will get a predictable result as far as the fit and the optics, and have a multifocal for your corneal scleral designs.